So it's the fourth time that I end up recording this video due to memory corruption issues. My SD card is not working too properly. And in our previous video we had discussed, we had learned how to take the derivative of functions where it is that a variable is raised to any power, whatever that power may be. You can take the derivative by dragging the power down and then subtracting 1 from the current power. However, whenever it is that you are taking derivatives of more complex functions, such as products, quotients, or composition functions, or anything of the sort, there are a handful of derivatives that need to be memorized in order to take the derivatives of these more complicated functions much more easily. So what I'm going to be covering in today's video are going to be the derivatives of the trigonometric functions, which I had already covered. If you happen to see all of the limit definition of the trigonometric function videos that I had released not too long ago, all of those are proven for you. We'll be covering trigonometric functions, inverse trigonometric functions, and exponential and logarithmic functions. If there are any other derivatives that I have not covered in this video, I will release them in another video in the near future. But the significant ones that you need in order to pass Calculus 1 are the ones that I will be putting up on the board right now, starting with the trigonometric functions. And you already know, based on the videos that I released not too long ago, that the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. And a quick comment on the derivative of sine of x: this is a cyclical derivative where it is that it will be cycling back and forth between sine, cosine. Sine will become cosine, cosine will become negative sine will become negative cosine, and negative cosine will revert back to its original positive sign. So it will continue back in a circle, just like that. Sine, cosine, negative cosine, sine, cosine, negative cosine, and it repeats itself to infinity. And the derivative of tangent of x is secant squared of x. The derivative of secant of x is secant x itself multiplied by tangent of x. The derivative of cosecant of x is negative cosecant of x cotangent of x. And finally, the derivative of cotangent of x is negative cosecant squared of x. And one of the tricks that really helped me out to memorize this list of derivatives that I have right here is that whenever you see a function that starts with the word co, that is going to have a negative derivative. So take a look at this. We have the derivative of cosine of x is negative sine of x. The derivative of cosecant of x is negative cosecant of x cotangent of x. The derivative of cotangent of x is negative cosecant squared of x. A co-function will have a negative derivative. And with all of that being said, we'll move on to the exponential and logarithmic functions. Now there are 4 exponential and logarithmic functions that are considered significant, and those are the derivative of the function e to the x, which is e to the x. The derivative of e to the x does not change. It stays e to the x. No matter how many times you take its derivative, it will constantly be e to the x, e to the x, e to the x, e to the x. Now the derivative of a to the x, where it is that a is any constant that is not e, will be a to the x multiplied by the natural logarithm of a. And this works out with e too, because if you were to substitute in e for a, essentially what it is that you would be left over is e to the x multiplied by the ln of e. But because the ln of e is defined to be 1, it will be crossed out and all you'll be left with is e to the x. And then we have the logarithmic functions, which are the derivative of ln of x is 1 over x. And then you have the derivative of log base a of x is 1 over x log of a. And that's pretty much it for all of the exponential and logarithmic functions. Derivative of e to the x is e to the x. Derivative of a to the x is a to the x multiplied by the ln of a, natural logarithm of a. The derivative of ln of x is 1 over x. That's a very significant one. Make sure to have that one committed to memory at all times. And then the derivative of a slightly less common one is the logarithm base a of x. That's going to be 1 over x times the log of a. And then finally, we'll move on to the last 6, which are the inverse trigonometric functions. Now, one comment I'd like to make about the inverse trig functions is that people call them by different names. I like to use the word arc whenever it is that I'm talking about a inverse trigonometric function. So I like to call sine inverse arc sine, cosine inverse is arc cosine. They mean the same thing, but they're in different notation. So if I were to write arc sine of x, it is exactly the same thing as sine inverse of x. And with that being said, let's start the list where we have the derivative of arc sine of x is 1 over the square root of 1 minus x squared. Then we have the derivative of cosine of x, which is the complete negative of the derivative of arc sine of x. All it is this repeated, but with a negative sign out in front. So negative 1 over the square root of 1 minus x squared. Then we have the derivative of arctangent of x, which is 1 over x squared plus 1. Then we have the derivative of arcsecant of x, which is 1 over the absolute value of x multiplied by the square root of x squared minus 1. Now, the absolute value only needs to take effect whenever it is that you have x values which are less than 0. If you have all positive values, then the absolute value can be dropped. Then we have the derivative of arc cosecant of x, which is exactly the same thing as arcsecant of x, but with a negative popped out in front. So we have negative 1 over the absolute value of x multiplied by x squared minus 1. These are exactly the same thing, but one has a positive sign, one has a negative sign. And then given this pattern where we have a positive and a negative, we can guess that the derivative of arctangent arccotangent is going to be the negative of the derivative of arctangent. So the derivative of arccotangent of x is exactly the same as the derivative of arctangent, but with a negative popped out in front. Negative 1 over x squared plus 1. And if you don't want to learn this list of derivatives through the video, I have a PDF document on my website, which I will be sharing the link to in the comment section below. If you are interested and you want that PDF document, go ahead and follow that link. And that's it for this video. In the next video, we will be covering product rule, how to take the derivative of products of two functions. And we will be using this entire list of derivatives that we had just learned today, so make sure to familiarize yourself with them in order to make use of product rule, quotient rule, and chain rule much easier for you. And I will see you guys in the next video.